In part two of our series, Examining Correlations, I want to talk about a couple real world examples. I always think it's best to take a look at some real articles that have utilized that statistical method and that design to better understand how they're structured and what they can tell us. So, the first article that I want to talk about is a study, a fairly simple correlation, where they wanted to look at the correlation between hammer throw performance and weight throw performance in the development of U.S. collegiate throwers. So, these are highly skilled throwers, and they looked at the two events that they participate in. The hammer throw, for those of you not as familiar with track and field, the hammer throw is an outdoor event. A weight is at the end of the entire hammer. They swing it around and they throw it as far as they can. Can't do that on the inside, so they use a weight throw. A weight throw is the indoor equivalent of the hammer throw, performed in a similar way but different because the object is not as long and it's heavier. And that's because obviously it's inside. It's really bad to throw around these really heavy things and so on. So the weight throw is an indoor event. And the question is, if I'm a coach of this event, again, I want to know should I have people train only for the hammer or only for the weight throw? If I do one, does it negatively or positively affect performance in the other? Again, so what's the relationship here? And then also, I see a relationship between the two events as well? So the questions that they had was, does again training for one affect the performance of the other, positively or negatively potentially? The author who is, I believe, a throwing coach, has seen multiple times where somebody might be really good at the one but not good at the other. So maybe if our goal is really to produce the best hammer thrower, we shouldn't have them do the weight throw or vice versa. Again, and then also, can performance in one predict performance in the other? Which would be helpful because then when we're in the indoor season, we know that if these two are positively related, then if I improve their performance in the weight throw during the indoor season, that will also potentially improve performance during the outdoor season. So they also wanted to see how closely their theoretical correlation between the two, which basically would allow you to correlate the weight throw in feet to the hammer throw in meters, to see if that's a perfect one-to-one correlation. So they wanted to compare this theoretical correlation to what actually exists in the real life. So correlations, in the correlation we're going to see here, they talk a lot about this line of best fit. I mentioned it in the first unit, but we'll see it much more closely here. Correlations research, we typically graph these correlations like we did for height and shoe size on a graph, where we can look at the relationship between those numbers, but then also form a trend line or a line of best fit based upon the data that we've gathered. I don't know if you remember from algebra the formula for a line. That's what I have listed here. Remember, the formula for a line was something like y equals a times x plus b. In this formula, x and y are the variables that we're correlating. So in this example, we want to see if the weight throw in feet is related to the hammer throw in meters. So one of those, in this case, the weight throw would be the y, and the hammer throw would be the x. Remember, A is the slope of the line of best fit, and we're going to see an example of this here in a second. And then B, remember, was the y-intercept, where the line crosses the y or vertical axis. So whenever you do a correlation, when you run it through the statistical programs that we utilize, not only will it spit out an R value and a P value, it's also going to spit out a line of best fit. And that line of best fit tells us the slope, how much one variable goes up as the other variable goes up or down. And then again, also shows us where it crosses the the y-axis. So again, that's the purpose of this study, was to look at the relationship between these two variables. And that's typically what we see in correlations. So just like we did with height and shoe or foot size, we see a very similar type of graph, right? So what we see in this graph is the weight distance, how far they could throw the weight in feet, and how far the same person could throw the hammer in meters. So, each one of these dots, this dot here, is a person. So that person threw the hammer about, maybe 60 or 59 and a half meters, and they throw the weight about 52 feet. So that's one person. Here's another person. Here's another. And we can see that when we look at this graphing of these numbers, that, there is generally an upward trend that as people throw further on one, they throw further on the other. So just in visual inspection, we can say, hey, there might be a relationship there. There could be a correlation. The dotted line is the line of best fit that the statistical program kicked out. And then obviously we get an R value. So the R value in the study, that's the correlation. That's 0.52. If we go back to our graph, that says that's a moderately strong correlation. So there's a moderately strong correlation between hammer distance and weight distance thrown. That means if you throw further in the hammer, you're likely to also throw further in the weight. So again, shows that there's a moderately strong correlation. And these are the findings for the women. I'll show you the men on the next slide. So it says that in women that, again, if they throw the weight further, I can guess that they will be able to throw the hammer further. So during the indoor season with my training, if I see that they're improving in their ability to throw the weight further, they're probably going to be also improving in their hammer throw. All right, so again, it does show that there's a relationship. There is still a p-value. We've learned about p-values on other units. The p-value tells us if the correlation is statistically significant. So since the R is 0.52, which says it's a moderately strong correlation, the p-value is significant, it tells us we can be confident that this is a real relationship between these values. So it tells us that there's a moderately strong, statistically significant positive correlation, meaning as one number goes up, the other also goes up. So that tells us we can be pretty confident if I'm a woman that is involved in the hammer and weight throw, that if I can throw one further, I'm likely to be able to throw the other further. So again, that's what this study found in regards to women throwers. Let me go back. I forgot. Also, this tells us the line of best fit. It tells us that the slope of the line is 0.79, meaning that, again, as one goes up one, the other goes up. So as hammer distance goes up 1 meter, my weight distance that I can throw goes up 0.79 feet. So it isn't a 1-to-1 ratio like they proposed, but it's close, that basically for every additional meter I get in the hammer throw, the individuals get about another 0.79 feet in their distance in their weight throw and vice versa. The men had very similar results, but again, a little bit different. So for the men, we do see a little tighter grouping and slightly higher, a stronger slope, a more upward slope than the women. But we get an R value of 0.75. So that's a stronger correlation. That actually gets us out of the moderately strong range into the strong range. It's still a positive correlation because as one number goes up, the other goes up. And it was statistically significant as reported in the article. So what we see for the men is a stronger correlation than the women. And again, what we see is that as one goes up, the other goes up. The slope of the line, however, is almost 1. It's 1.00. So again, for each meter of hammer distance, the men get about a foot of weight distance and vice versa. So again, if you throw one far, then you also throw the other further. So again, we see that there is a relationship here. So what this tells us practically, right, is that if I'm in the indoor season and I'm doing exercises and doing training that's increasing the individual's ability to throw the weight further, I'm probably also helping the individual for the outdoor season for their hammer throw. So again, it gives us some ability to say that, yeah, we shouldn't pull the people out of one or the other and focus on one. We can still work on both, even though the techniques are slightly different. And the final graph I wanted to show you from the study related to hammer and weight throw compares the two lines of best fit for the men and the women, but then also the model that was proposed by the researchers. The researchers proposed that, again, basically there would be a one-to-one relationship between hammer distance and weight distance, meaning for each additional meter you can throw the hammer, you get one additional foot on the weight, and so on. And they were very close to that model that they proposed. It was almost a one-to-one ratio, but a little bit more. And for the women, we see that that was a little less. That's why when we look at these three lines, the blue is their theoretical correlation. The orange is the men's, which almost exactly mirrors it. It's just up a little. The raised above it a little bit. And then we can see that the women have a slightly downstroke, meaning, again, that relationship between hammer distance and weight distance, the increase that we see in hammer distance compared to weight distance decreases as people get farther and further in their throws in the hammer. But again, it still very closely models that. And they have very similar results between both men and the women. So again, it tells us a little bit about training and that we can train people for both of these events. Enhancements in one event will potentially carry over to the other event as well. The second study I wanted to mention, very interesting, and it throws a ton of numbers at you. But again, I think you're ready for it. So these researchers, what they wanted to examine was, is there a way to predict success in wrestling? Is there a way to predict success based upon certain physical performance abilities, certain anthropometric measurements like arm length, height, weight, and so on? And then lung capacity, some measures of ability to bring air in and out of the lungs and then exchange oxygen more quickly and more efficiently. So they measured a whole bunch of different variables that would all be the predictor variables to one criterion variable, which was performance in wrestling. So let me talk a little bit more about what they wanted to do and what they measured. So the purpose was to evaluate how these different measures potentially could predict performance in wrestling, with the idea being, are there certain people based upon these types of measures that are better suited to wrestling? Some of these factors are just determined genetically. Some of them can be altered by training. So is there certain things we should focus on in individuals if our goal is to make them elite wrestlers? So what did they measure as, again, these independent variables or as these predictor variables? First, they measured lung capacity. They measured maximal oxygen consumption. They also measured things like tidal volume, residual volume, the different aspects of lung function and lung volume, and how things that could affect performance, especially aerobic performance. They also measured aspects of physical fitness, which they included hand grip strength, deadlift, squat, bench press values, sit and reach, flexibility of the hamstrings, etc., agility, and then reaction times in a variety of different areas of the body. A really comprehensive physical fitness test. And then they took a bunch of anthropometric measurements, such as wrist and shin circumference, which indicates things like, again, skeletal size, skeletal mass. They looked at trunk height, arm span to height ratio. So if you have long arms for your height, is that beneficial? They looked at height overall, weight overall, body mass index, body fat percentage, and so on. And they compared all of those things. They correlated all of those measures with wrestling performance. Now, wrestling performance, that's harder to give a number to, right? So what they did was they allocated points to the individual subjects in the study based on first, second, and third place performances at either provincial, which would be correlate to kind of our states, national, and official tournaments over the last 3 years. So they measured wrestling performance based upon, again, how often they finished in the top three. And that in turn gave a numerical score related to wrestling performance. So kind of an interesting methodology that they utilized there. So what did they find? And again, lots of tables here because they measured a lot of things. And remember, what we're interested in are the correlation coefficient, that's the R value, and then the P value. Was it statistically significant? So we want to see both potentially. So when you look at these different measures like height, when they correlated height with wrestling performance, the correlation coefficient was 0.3. So it says there's a moderate correlation, but it was not statistically significant. So when you look through and you look at the statistically significant anthropometric measurements, we only see two: body fat percentage and arm span. So let's talk about what that means. So body fat percentage, so that's, again, what percentage of their body is lean or body fat. They found a negative correlation coefficient, and it was statistically significant. The correlation was 0.42, which says there was a moderate negative correlation between body fat percentage and performance. So as body fat percentage went up, that means performance went down. So wrestlers with a lower body fat percentage tended to do better. That makes sense, right? Based upon performance, they have more muscle mass per body weight, so maybe carrying around a little less weight. So anyway, that was one significant thing that they found, that wrestlers with lower body fat percentage did better than wrestlers with higher body fat percentage. Arm span, and this is again controlled for by height. So if you had longer arms for your body height, then you also there was a positive correlation, 0.6. That's a moderately strong correlation. So wrestlers with a larger arm span significantly performed better in wrestling. Interesting, right? Now, that isn't something that we can change. So I don't know that that means a lot to us unless we're maybe involved in youth wrestling and we're going to encourage and discourage certain people from participating. But it did show an interesting, again, a relationship to performance. When we get to some of the other measures related to physical fitness traits, there was a lot of significance here. In general, we saw positive correlations between, or they saw positive correlation between deadlift ability, squat ability, bench press, maximal oxygen consumption, agility, shoulder and wrist elevation measures. That's a flexibility measure. Sit and reach ability all had positive correlations, all pretty strong except for agility. A significant correlation to wrestling performance. Now, a lot of these can be changed with training. So again, that would be something that if you work with wrestlers, we would want to consider including as goals in our training program. Because again, if they can lift more, they performed better in this group of athletes. There was also a negative correlation between reaction time between the eye and the left hand. And then again, negative correlation in reaction time between a number of the measures and wrestling performance, which is interesting. So reaction time had a negative correlation. Oh, actually, this makes sense. A quicker reaction time, a lower measure of reaction time, yielded more an increase in wrestling performance, which makes sense, right? So if they were better at reaction, they also did perform better, except for the ear right hand reaction time, which they saw a positive correlation. So again, it does show that potentially in general, reaction time improvement also enhanced wrestling performance. On this third one and the final one, they looked at the correlation between lung capacities and wrestling success. And some of these are potentially changeable with training. Some are not changeable with training. But they found, again, some positive correlations between ability to move air in and out of the lungs, such as tidal volume, forced vital capacity, forced expiratory volume, and maximal voluntary ventilation, which all can be changed somewhat with training, endurance training, all helped and were positively correlated with wrestling performance. So it seems that in addition to improving strength in a number of areas, improving function of the aerobic system, the lungs is going to also positively correlate with wrestling performance. And again, these were fairly strong, moderately strong, moderately strong, strong correlation with wrestling performance. So again, it gives some guidance in designing a training program for wrestlers. So hopefully these two examples again show us what an R value is, a correlation coefficient, and the p-value, and how those impact the relationship between a predictive variable and an outcome or criterion variable. Correlation research is done very frequently in our field and can provide some really useful information for us about a population and about different types of training techniques and so on. So anyway, that brings this unit to an end. Hopefully you've learned a good bit about correlations research, how to interpret it, how to read those studies, and then how to utilize that information in making your professional decisions along with your clients and so on, and helping them meet their goals. As always, again, I did utilize the text Research Literacy, a primer for understanding and using research in developing this presentation. And then the two articles that I summarized are listed here as well. That's it. Hopefully you go out and find some really interesting correlations research to read on your own, and have a great day.